Hey there, stats enthusiasts. Welcome to our brand new series in Unit 3, Collecting Data. This is the first video that is going to cover Notes 1, Types of Studies. So this is going to be all about the different types of studies we have, going over observational studies, experiments, sample surveys, you name it. We're going to talk about it today. So get ready to take some notes and to learn some amazing content. As we start talking about the different types of studies, let's look first at how we kind of gather data just in a broad sense, right? So when we want to gather data in a way that we can analyze it, we usually want the data that we gather to study some type of population. Now, the population is what we want information about, a group we want information about. So when you think about population, it's not just everything or everyone. The population can be broad like that, but the population can also be very specific. Population can be a specific population of a state or a specific population of ages in that state, or a specific, high school in that state, right? We can get very specific with our population or very broad. Now, there's usually challenges involved in analyzing a whole population. So in many studies, what we're going to do is collect a sample, and we use a sample. And a sample is just part of the population we examine in order to gain information about the whole population. And we want that sample to be what we call representative of that population. So when we choose that sample, we want it to be in a lot of ways like a mini population itself, so that we can analyze the sample, get our data, whatever we need, and then apply it to the whole population. So when we look at our example here in the notes, it says match the population with the sample by writing the letter on the line. And what we want to do when we set this up is we want our sample to represent our population. So if we look at that first line there with our population, let's say our population is all Illinois residents. Now, again, there's challenges with analyzing all Illinois residents. So we want to take a sample that represents all Illinois residents. So if I look over there at my choices, which one is going to accurately represent all Illinois residents? Is a sample of 10 of our school students going to represent all Illinois residents? Well, if our school is in Illinois, first off, if your school is not in Illinois, then it definitely won't. But would 10 students from our school represent all Illinois residents? That's probably not going to happen. That's not going to be a good representation of our whole population. What if we took a sample of 10 U.S. high school students, just U.S. high school students in general? Again, that's not going to accurately represent all Illinois residents. 10 students in our class, not a good choice either to represent all Illinois residents. But for D, if we take a sample of 10 Illinois addresses, that could be a good representation of all Illinois residents, because if you have an Illinois address, you are an Illinois resident. So that's why our first population to sample match is going to be all Illinois residents for our population. And the sample, we take a sample of 10 Illinois addresses. So that's the connection we want to make between these population and samples. We want them to be, the sample to be representative of our population. So if we look at all U.S. high school students, we want to select a sample that comes from all possible U.S. high school students. So for B, if I take a sample of 10 U.S. high school students, that's going to represent the larger population of all U.S. high school students. If I wanted to look at all students at our high school, and if that was my population, then my sample should be 10 of our school's students, right? Now, why wouldn't C be an answer there? Well, a sample of 10 students just in our class, would 10 students in our class represent the opinions and beliefs and data analytics, whatever you're gathering, of all students at our high school? It might not accurately represent that. We want to make sure we accurately represent our population with our sample. So if our population is all students at our high school, we want our sample to reflect all possible students at our high school. And then last, if our population is small, and let's say we just care about the students in our class specifically, if that was our population, then we can take a sample of 10 students in our class. Then that would be an appropriate sample to take that represents that population. So you can see here, population can come in many shapes and sizes, as can our sample. Okay. Well, I guess in this case, our sample, we just took 10, but your sample can be small in terms of like just 10, or it can be larger, like 100 or 1,000. Your sample can be various sizes as well, just like your population. So that's a little bit about gathering data. We have to make sure we understand the difference between our population and the sample we gather when it comes to analyzing our data. So we can analyze data by looking at, beliefs, looking at opinions, looking at statistics of some kind like height or weight. We can analyze any type of data we gather from a sample. But it's important to keep in mind some of the numbers we get from it. A statistic is a value that describes a sample. And we talked about statistics before. When we have our X bar or our S, those are our mean and standard deviation of our sample. Versus a parameter is a value that describes a population. And usually we get this value from a statistic. It's given to us from gathering a sample and getting a statistic and then applying it to the population at large. But the difference between statistic and parameter is important. So a way I help students remember it is S, statistic starts with S, and so does sample. And parameter starts with P, and so does population. Okay? So keep those straight as we move throughout the units, that we understand certain values come from a sample, but then certain values we ascribe to a population. So here in these examples, we want to identify what the population and sample are, as well as the statistic and parameter that describe them. So I just have two situations here. The first situation says the average height for a 15-year-old female at our high school is 5'4". A sample of 10 females at our high school have an average height of 5'7". So what's our population here? Our population is the larger description of who we're getting information about. So in this case, our population will be the 15-year-old females at our high school. Okay? And they're specific about 15-year-old females. So it's not all students at the high school. It's not even all females at our high school. It is specifically 15-year-old females at our high school. And that's our specific population. Now, what number describes our population? That's going to be 5'4". Okay, so we make a statement about our whole population, and we say our whole population of 15-year-old females at our high school, their height is 5'4". We say we take a sample of 10 females at our school, and they have an average height of 5'7". Okay. Now the 10 females at our school, we would hope that those 10 females would be 10 15-year-old females. That's something we always have to be aware of when we collect data for a sample. We want our sample to represent our population. So if it was just 10 whatever age females, even, staff members at our school, because it's not even specifically saying students at this point, it wouldn't accurately represent our population. So when we identify this, our population, all 15-year-old females at our school, our sample is 10 females at our school. Okay? And we're going to make sure that a good sample is 10 15-year-old females at our school. The parameter is 5'4". That describes our whole population. And our statistic is not equal to our parameter, but we expect that, right? We've had enough conversations about this idea of sampling variability. Now, how when we gather a sample and we get data, we do expect some variability from our parameter. Now, of course, we'll get a lot deeper in that discussion in the coming units, but the difference between parameter and statistic right now, we're just identifying it in a situation. Okay. So the second situation here, high school students in your county work an average of 18 hours per week. If you take a sample of 50 high school students in the county, and it was revealed that they worked an average of 23 hours per week. what's your population sample statistic and parameter? So your population here is going to be high school students in your county, in our county, and our sample is 50 students in our county, okay? 50 of those high school students we took a sample of. Our parameter was 18 hours per week. That described the population. And then our statistic, when we surveyed those 50 students in our county, we found that they worked an average of 23 hours per week. Okay? So be able to identify them, and we'll talk a lot more in the coming sections of notes about how we can make sure that our sample accurately represents our population. Now, types of studies. We're going to go over the three big ones today. First up is observational studies. Now, in observational study, researchers observe subjects and they measure some sort of variable that they're interested in, but they don't attempt to influence those variables at all. They just observe what's already naturally occurring. So there's no treatments being applied by these researchers. And what they do is attempt to make inferences or, draw conclusions about the population. So they look at a sample in order to draw some conclusion about the population at large. Now, most observational studies cannot draw like a cause and effect relationship. We'll talk about the type of study that does draw that. Some do attempt to draw and study correlation between two variables, but remember, they cannot imply causation. So we just came off of a unit where we talked about correlation does not equal causation. That is still going to be a very true statement throughout these units, okay? And a big reason we talked about in the last unit is because of lurking variables. It makes it very difficult to establish causal links between two variables in an observational study. So observational studies are being measured in some sort of natural setting, right? So researchers aren't attempting to impose any treatments or influence their environment in any sort of way. We just observe what is already occurring. Now, there are some situations where we will not be able to ethically set up and study a cause and effect relationship, where in an observational study is the only way to develop a cause and effect relationship. For example, smoking and lung cancer, right? We don't have a good way of setting up an experiment. So, telling these people, okay, you guys are going to smoke for a year and you guys are not going to smoke for a year, and we're going to see who develops lung cancer, right? That would be very unethical to make people smoke and make people not smoke. So the best we have about the correlation between smoking and lung cancer is through long-term observational studies. Okay? So when you see some of these headlines and you see that they are establishing a correlation, dieting while pregnant and the result of birth defects, or how consuming alcohol leads to more aggressive behavior. When you're seeing studies making this correlation between what they're observing, that's because a lot of the times they just don't have a choice. Okay, it's unethical to set up experiments that test these things. So in the big picture, though, most observational studies are going to just observe in the natural setting, and we use the results to describe the population in some way. Now, I do have two examples where I want us to be able to identify the explanatory and response that we're studying and identify lurking variables. We did a little bit of this in Unit 2 in our last unit, but it's important just to keep practicing it and making sure we understand what's happening in the situation. So for this one, for a sample of subjects, you record how many hours of exercise they get each week and the number of colds over a year. So this is an observational study because we're looking at how many exercises they get each week and how many colds they get over a year. So the researchers aren't imposing a treatment. They aren't saying, okay, you guys do this, you guys do this. They're just observing exercise and number of colds. So it's an observational study, and they determine that there's a strong negative relationship between exercise and colds, and that the more you exercise, the fewer colds a person had. Now, there is an explanatory and response variable here. The explanatory would be the weekly exercise, how many hours of exercise they got each week, and the response is how many colds they got. And they claimed a strong negative relationship in this observational study. Now, that would be incorrect in this case to draw that conclusion. It's fine to observe that in an observational study, like, hey, this is what we observed, but we don't want to make the statement that there is a cause and effect relationship because of the possibility of lurking variables here, right? There's a lot of variables that come into play in terms of weekly exercise and number of colds. Diet, exposure to different pathogens, the immune system of a person, the type of exercise they are doing, right? There's a lot of variables that play into both what determines someone's weekly exercise as well as how many colds they get a year. So because of this, this is an observational study. We are gathering data, but we don't want to draw that cause and effect relationship too quickly. Same thing here. To investigate the correlation between SAT prep and SAT examination, they collect data on a sample of people who take the SAT from 3 different high schools. First, they identified the number of SAT prep classes that they attended, and then gather the SAT exam scores for each of the students. Now, we can identify this as an observational study because the researchers just gathered the data. They did not impose a treatment. They did not say, hey, you students attend class twice a week. You students don't attend any classes. There was no being told what to do. They just recorded how many classes they took and what their exam scores were. And again, this is fine. This is a good observational study. We can identify the explanatory and response in this observational study. SAT prep classes attended versus their SAT exam score. But we're not going to draw a cause and effect relationship in this observational study because of the possible lurking variables here. Okay. The best we can do is just suggest a casual relationship like, hey, this is what we noticed in this observational study, but we're not going to draw a cause and effect relationship because there are so many things that play into both those explanatory and response statements. Okay. Observational studies. We're just gathering data. We're just gathering information that already exists. Okay? A specific type of observational study that we use is a sample survey. Okay? So a sample survey is a subset of an observational study where researchers use questionnaires or interviews to collect information. So you're not looking at necessarily information that's already available. You do have to go out and gather the data, but it is still a form of observational study because you are just observing what is already there. Okay, it might be opinions or it might be some sort of factual information. So, like, what's your opinion on who's running for president? Or it could be factual information like, okay, let me gather your height and your weight. Like, tell me what it is. Sample surveys are used across the board for those types of informations. And now a census is a specific type of survey, not a sample survey, but a specific type of survey where you collect data for all individuals in the population. Now, there's difficulties involved in taking a census, which is why, like in the United States, we take a census every 10 years. And it happens every 10 years because it's a lot. It's a lot that goes into it. It's a lot of data gathering. So it's not done that often. And for researchers, it is pretty inconvenient. Just getting a hold of everyone in the population takes a lot of time, takes a lot of money. So a census really isn't used often as much as we do use a sample per se. A sample is best when it is randomly selected. That is, the probability of selecting the sample is the same as the probability of selecting every other sample. And we'll dive more into this definition in the next set of notes, where we talk about how we randomly select a sample. But a sample is best when it is randomly selected, because if you don't randomly select, a form of bias is introduced. And bias influences the study in favor of one outcome over other outcomes. And again, bias, we'll get into the different types of bias that exist when we collect a sample. We'll define them and talk about them. But I'm just introducing these terms now because they do come up pretty often when we are setting up our different types of studies. Okay. So along with a well-designed random sample, which will help eliminate bias, a well-written survey will also allow us to make sure we obtain reliable responses that actually represent the population that we're interested in. So when you write a sample survey, you will need to decide what types of questions you want to use and then how to word those questions. So there's two types of questions you can ask. You can ask an open-ended question or a closed-ended question. So an open-ended question is when you ask the person doing the survey to write comments or free response or anything that the user can just openly type or write down. And a closed-ended question is when you give them a choice, right? Like a yes, no choice, multiple choice, ratings, whatever that may be. They're limited in the number of responses they could do. Okay. So in addition to deciding what types of questions, you also want to make sure that you write a good question. Okay. And there's three really key points when you're writing a good sample survey, is that you speak your audience's language. Okay. So speak your audience's language means that you're not using vocab that is too high level or too low level for your specific audience, right? Keep it simple. Don't add more information than you need. And then stay balanced, not biased. So make sure you're not introducing your own opinions into the questions. Now, the advantages of surveys is that you can collect it in various forms. So you're going to see examples in this class about collecting data by telephone, by mail-in survey, online survey, of course, is popular, but also like face-to-face interviews, or when we do our project in our class, it's going to be via survey slips. There's a lot of different ways we can give out a survey, which makes it very convenient. It also makes it efficient for collecting data from a large population without using too much of your time, okay? Because all of these are kind of passive ways of collecting surveys. Now, except I guess face-to-face interviews, that's pretty, that could be pretty time intensive. But otherwise, if it's like, let's say just a mail-in form, you just send out the mail surveys and just wait for them to come back, right? So you can also design a survey so that it focuses on only what you need. So only what your data is being collected, you can focus your questions on that. And then, of course, it's applicable to a wide range of topics. We use surveys throughout various courses to collect information. The disadvantages is that it does the disadvantages is that it does depend on our people's honesty and motivation when answering. Okay, and it can be flawed by bias because of this. And we're going to talk more about that in the next couple sections of notes. The last type of study we are going to talk about is experiments. So I'm just going to give you a brief introduction to experiments now. As I've been saying, we're going to expand on a lot of these ideas in our later sections of notes. So in an experiment, researchers impose some sort of treatment on experimental units in order to study their responses. Okay? Now, the purpose of this is to study whether a treatment causes a change in the response. So through an experiment, that's how we establish a cause and effect relationship. Okay. So when the experimental units are human beings, we usually call them subjects. Okay. So you'll see experimental units could be, plants or animals. But when they're humans in an experiment, we usually call them subjects. So you'll see those two terms kind of used interchangeably when talking about the people or the things in experiments. So in an experiment, just like with an observational study, we have to be aware that there are lurking variables. In an experiment, we have to be aware of what's called confounding variables. And confounding variables are variables that are included in the design of a study unintentionally, and their effects cannot be distinguished from explanatory and response. We'll dive deeper into the differences between lurking and confounding, as well as how we identify them and how we can potentially control for them in our later section of notes. So when an experiment is a controlled study, because you want your experiment to be as controlled as possible. You are not doing anything usually in a natural setting here. In an experiment, you want to control as many variables as possible. And usually at least 2 groups are used for comparison. One of the groups is exposed to a treatment, while those in a separate group are not exposed to a treatment, or maybe they're exposed to what we call a placebo. And a placebo is a quote-unquote dummy treatment that appears the same as the actual treatment, but in fact has no effect, right? So a common example that I use is, if you're testing out a new depression medication, right? In one group of people, you give the depression medication, and in the other group of people, you don't want to give them the depression medication. But for those people who don't receive the depression medication, you want to give them a pill that makes it seem like they're getting the medication, but it actually is inactive, right? We call that a placebo, a dummy treatment. So in order for an experiment to be totally controlled, we do that because they need to believe they are experiencing the same conditions. If we're testing out a new depression medication, we need everyone to believe that they are getting the treatment when they are actually not getting the treatment, right? So we do that in order to, at the end, when we compare the 2 groups and say, okay, whose depression, did the depression of the people who took the drug, did it help with their depression, or was there really no change between the 2 groups? We compare them at the end to make sure that we can say, okay, the results we're going to attribute, if there was a difference between the depression scores, it could be due to the drug. Right? Now, there's this thing called the placebo effect, though, which is actually very interesting when subjects respond favorably to a placebo as if it were the actual treatment. So going back to the depression pill example, if at the end of the study they looked at both groups and they're like, you know what, actually the depression of everyone improved. Everyone in the group that took the actual depression medication, their depression improved. And then everyone, even in the placebo group, their depression improved. Okay? We call that the placebo effect. And truth be told, we don't know why it occurs. We think it has something to do with, the power of the mind and just how powerful, if you think you're receiving the treatment, your mind is going to say, oh, you're going to get better. You're going to start feeling better. And then all of a sudden you do. That's the working theory, at least. But truth be told, we don't know why it occurs. It's actually a very interesting phenomenon. So in order to kind of help with the placebo effect, in order to, again, control our experiment as much as possible, we also have 2 ways to describe a study, single blind and double blind. Now, a single blind study is when researchers are aware of the subjects and what treatments they are getting, but the subjects are not aware if they're receiving the actual treatment or placebo, right? And at the minimum, you want a single blind study. You don't want the subjects to necessarily know what treatment they're getting. A double blind study is even better, where both the researchers and the subjects are unaware of which subject belongs to the control group. So the researchers won't know, okay, are you getting the depression medication or are you getting the placebo? I don't know. And the reason why that is sometimes better, as we'll see, is because the researchers can impact the subjects unintentionally in their attitudes, in the way they treat them, and in those little ways of interacting with them. So a double-blind study is better because it helps eliminate some of those confounding effects. Okay. So that's just a brief introduction into experiments. We're going to go a lot deeper into what all goes into an experiment and look at some good experiment examples in later sections of notes. I want to end this section of notes with a few examples. Okay. Oh, and before I end, I do want to say this. The best experiments are randomized to where the subjects or experimental units are randomly assigned to the treatment or control group, that they are comparative, meaning that they compare 2 or more treatments, that they're double blind, right? Researchers and subjects don't know the treatment that they are receiving, and placebo-controlled, meaning that you do have that control group and you do place a placebo if necessary. Okay. So here are the 4 examples we are going to be looking at. And I just want you to be able to determine, is it an experiment or an observational study, and explain kind of why, right? We want to be able to identify which is which, because, as I've hinted, it allows us to make different conclusions. An observational study is just applying a result to a larger population, like, hey, we found this out, and we can apply it to the larger population, versus an experiment where we can actually draw a cause and effect relationship. Okay, so like for number 1 here, a medical team examines the records of 5 large hospitals and compares the survival times of those cancer patients who had surgery versus those who only had chemotherapy. Okay. Now, is this an experiment or an observational study? Well, in order to tell the difference, you have to ask, is a treatment being imposed? Did this medical team impose the treatment? And now when we say treatment, we mean, did they tell people, hey, you as a cancer patient are going to have the surgery, or you're going to be assigned to chemotherapy, and we're going to see who survives in the end, right? So when you phrase it like that, it sounds kind of silly in this example. This is an observational study. The medical team did not make people do that. The team did not impose the treatment. They just recorded what had already happened. Okay? They did not say, okay, you are going to have surgery or you are going to have chemotherapy. They did not give the treatment or impose the treatment. They just recorded what already happened. And versus in number 2, in a gym class, the effects of exercise on blood pressure is studied by requiring that half the students walk a mile every day while the other half run a mile each day. So you walk into gym class and your PE teacher tells you, okay, I'm randomly assigning you to either walk a mile or run a mile, and we're going to see, we're going to measure your blood pressure at the end of that, right? This would be an experiment. Okay? Students are given the treatment. Your PE teacher will tell you, okay, you are walking or you are running. And then the response of the blood pressure is being recorded. Okay? Our last 2 examples. At the zoo, they want to study the relationship between the length of a snake and the snake's weight. So they take a random sample of snakes and record information. This would be an observational study because there's not a treatment. We are just observing what is already occurring, right? We're not changing diet or exercise or anything of the snake. We're just observing the length and the weight. Number 4, a group of smokers were randomly assigned to one of 2 groups. One group was told to continue to smoke their cigarettes like normal, and the other group was told to cut the number of cigarettes they smoke in half, and their pulses before and after were recorded. This would be an experiment, where subjects were being randomly assigned to one of the 2 treatments, and then their responses were recorded and compared. Okay? So this would be an experiment. Okay? And again, important to know the difference and identify the difference so that eventually we can determine what type of conclusions we can draw from these. And that wraps up today's video on Notes 1, Types of Studies. In the next video, we are going to be going over selecting random samples and talking about all the great stuff that goes into selecting a truly random sample. If you have liked this video, please go ahead and click the like button and subscribe to my YouTube channel for more great AP statistics content. Until then, I wish you endless statistical success, and I will see you in the next video.